We now discuss the solution of a problem that has appeared in the joint admission test for masters in mathematics in the year 2022. The problem is on the consistency of a system of non-homogeneous linear equations. This question is from the section Linear Algebra. This is the question number 18, and it is a multiple choice question for 2 marks. The given question is, consider the system of linear equations x plus y plus t is equal to 4, 2x minus 4t is equal to 7, x plus y plus z is equal to 5, x minus 3y minus z minus 10t is equal to lambda, where x, y, z, t are variables and lambda is a constant. Then, which one of the following is true? We are given 4 options. Option A, if lambda is equal to 1, then the system has a unique solution. Option B, if lambda is equal to 2, then the system has infinitely many solutions. Option C, if lambda is equal to 1, then the system has infinitely many solutions. Option D, if lambda is equal to 2, then the system has a unique solution. We are given 4 equations in 4 unknowns x, y, z, t, and in these lambda is a constant. Agreed. Then we have to decide for the various values of lambda, is the given system has a unique solution or infinitely many solutions. Before discussing the question in detail, let us recall a criteria for the consistency and inconsistency of a given system of non-homogeneous linear equations. Consistency, inconsistency of a system of non-homogeneous linear equations whose matrix equation is Ax is equal to B. And here A is called the coefficient matrix, and the matrix A along with the column vector B is called the augmented matrix of the given system. If the rank of the augmented matrix A with B is equal to rank of the coefficient matrix is equal to the number of variables, then the given system is consistent and the system has a unique solution. If the rank of the augmented matrix is equal to rank of the coefficient matrix is equal to the number of variables, then the system has a solution and it has a unique solution. If rank of AB is equal to rank of A less than the number of variables, then the system is consistent and the system has infinitely many solutions. Rank of AB is equal to rank of A, consistency will come, and they are equal, consistency will come, and equal to less than the number of variables, then the system has infinitely many solutions. If the rank of the augmented matrix is not equal to the rank of the coefficient matrix, then the system is inconsistent. That is to say that the system has no solution. Let's now discuss the solution of the problem in detail. We are given the system of non-homogeneous linear equations. The first equation is x plus y plus t is equal to 4. 2x minus 4t is equal to 7. X plus y plus z is equal to 5. X minus 3y minus z minus 10t is equal to lambda, where x, y, z, t are the variables and lambda is a constant. Agreed. We will now write this system of equations in the matrix form, and it is given by Ax is equal to B, where A is the coefficient matrix, that is 1, 1, 1, z position, there is no z here, the first equation, therefore 0, t 1, and 2, there is no y, 0, there is no z, 0, minus 4. In the third equation, 1, 1, 1, there is no t, 0. And the fourth equation, 1, minus 3, minus 1, minus 10. Capital X is the column matrix consisting of the variables x, y, z, t, and capital B is the column vector, column matrix consisting of the given values. Now, the augmented matrix is, we write down the matrix A along with the column matrix B. So, this is the matrix A and this is your B. This is your B. In between there is a screen. Right. This is the augmented matrix. We continue in the next slide. We have the augmented matrix. Agreed. Now, what is our goal? Our goal is to reduce this into an echelon form. To do so, we apply elementary row operations on this and bring into a row reduced echelon form. Now, we make these operations. R2 is, from R2 subtract 2 times of R1. R3, from R3 subtract the corresponding entries of R1. In R4, subtract the corresponding elements of R1. Thereby, we will make this position 0 and this position 0 and this position 0. Now, we write this is equivalent to, that means is of the same rank as above. The first equation as it is. The second equation is, you have to subtract minus 2 times the entries of R1. So, 2 minus 2 of 1, that is 0. 0 minus 2 into 1, minus 2. 0 minus 0. Minus 4 minus 2 times of 1, minus 6. 7 minus 2 times of 4, that is 7 minus 8, that is minus 1. So, also do for the third row, R3 is R3 minus R1, R4 is R4 minus R1. We get like this. Agreed. Now, the next one is this 2-2 position. This one and this one. So, this position, that is 4-2 position, we want to make it 0. And anyway, 3-2 position is 0. So, to do that one, R4 is R4 minus 2 times of R4. If you make minus 2 times of R4, this becomes 0. And this will be minus 1 as it is. This will be minus 1 as it is. And minus 2 times of into minus 6 is 12. Minus 11, that will be 1. And minus 2 times is plus 2. Add to lambda minus 4, it will become lambda minus 2. And the third row is unchanged because we have not touched the third row. Now, we want to make this fourth row, third column element to be 0. To do that one, to the fourth row add the corresponding entries of the third row. So if you add, so 1 minus 1 0 and 1 minus 1 1 0 and lambda minus 2, and you are adding 1 lambda minus 1. So that will be the third row is lambda minus 1. Agreed. Now look, these red ones, the red ones are now they are forming an echelon. Agreed. And it is the echelon form. And it is the echelon form. The rank of the coefficient matrix is the number of non-zero rows in this matrix. The number of non-zero rows are 3. Therefore, this is the echelon form. The rank of the coefficient matrix is 3. We continue in the next slide. We have the augmented matrix and reduce it to the echelon form, and the rank of the coefficient matrix is 3. Now, if lambda is equal to 1, suppose lambda is 1, then lambda minus 1 will be 0. So, this fourth row is completely a 0 row. Then the rank of the augmented matrix, is 3, and the rank of A, we have already seen it is 3. They are equal. And this 3 is less than 4, the number of variables. There are 4 number of variables are there. Let's recall our theorem. Rank of the augmented matrix is equal to the rank of the coefficient matrix. Therefore, it is consistent. And it is equal to 3 less than 4. Therefore, it will have infinitely many solutions. So, the system has infinitely many solutions. So, let's look at our options. And in the against option C, we have if lambda is equal to 1, then the system has infinitely many solutions, which is true. So, our option C is true. And if lambda is equal to 1, then the system has unique solution is obviously false. Therefore, option A is not true. Now, if lambda is not 1, it can be anything, lambda not equal to 1. When lambda not equal to 1, lambda minus 1 is not 0, then the rank of the augmented matrix is 4. Whereas the rank of the coefficient matrix is 3, they are not equal. Therefore, the given system is inconsistent and has no solutions when lambda not equal to 1. Therefore, in the case of options B and D, lambda is equal to 2, which is not equal to 1. Therefore, the given system is consistent and has no. The given system is inconsistent and has no solutions. Therefore, options B and D are not true. Because in options B and D, and we talk about the existence of solutions, but whereas it is inconsistent and has no solutions when lambda is equal to 2, which is not equal to 1. Therefore, options B and D are not true. The answer to this question is option C. So that is the detailed discussion of the solution of the problem on the consistency of a system of non-homogeneous linear equations from the section Linear Algebra. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.